So hey all, let's start today's session. Today's session is zero copy cloning, or we call also cloning in Snowflake. So as part of today's session, we'll see what is mean by zero copy cloning and what is the benefits or advantages of the zero copy cloning and how we are going to do this copy cloning, zero copy cloning, and what are the key points about this we need to note down during while practicing or while doing this cloning, and what are the objects basically can be cloned and what are the limitations with this cloning in the Snowflake we will see. So basically what is mean by a zero copy cloning? So before that, first we'll see that what is meaning of copying the data. So what is mean by copying the data? General meaning.
Sir, it's like
Place the
copy.
data in table.
Yeah, so it is a kind of whenever you are taking a backup or wherever you want to replicate the data again and again, we will do this basic copy. Copy means you are just duplicating the same thing, right? We're recreating another object, the same kind of object which is already available in the database. So now if you see in a real-time scenarios, like in real-time projects, we have a multiple environments, especially as I mentioned multiple times. I have mentioned one is kind of a production environment and non-production environment. So in non-production environment, basically we call as a dev and testing and production. So the production will be kind of a, we have a actual live data, and the data will be going to use the business teams. So we are not going to touch that production data directly. We cannot modify any object or we cannot delete anything in the production directly. So ideally they'll grant only read permission. Only very few people will have a admin access. I mean to say basically they can do whatever they want with the production data, but and rest of the people in the team, they'll have only read access, which means in production you can only select the data, you cannot delete or you cannot modify or you cannot drop any objects. So it is a kind of a precaution people will take care in a real-time projects. So in non-production, I mean to say dev, you have all the access and all. So whatever you want to modify in the production, first you will do that modifications in the dev environment, and then you will test that changes are working properly or not in the testing environment. Then if everything is looks good, then you will move that changes into the production environment by using a kind of a CI/CD practices we called. So that is a kind of a code deployment and all. That is a different topic. Okay, so that we'll see later, kind of a overview. So now when we are following this particular approach, this is a kind of a generic approach wherever you go, whatever the project you are going. So there are certain projects, it might not have a multiple environments, but at least they have a kind of a two environments. One is dev, other one is a production. So now in order to do this kind of a testing, in order to do this kind of a validations, so this is a common problem is, see now the dev will have a access everything for the developers, so they can do whatever they want. So after certain period of time, so multiple people are modifying or multiple people are dropping the objects. So after 2 to 3 months, if you see the dev database data will be completely out of sync with the production data. So now per suppose I am dealing with a 100 GB data and I am writing on particular SQL logic for the view creation. So now I want to test that particular SQL logic. Is it working as expected or not, or at how much time it is taking? So if I have a 100 GB data in dev, then it will be, I can execute this particular query and I can see how much time it is taking to execute that query to deal with this 100 GB data. But as I mentioned, in production, we have a kind of a actual data, but in dev, due to some time, multiple developers are dropping the objects or deleting the data. So like in dev, unfortunately, I don't have a 100 GB data. So now how I can test this particular scenario? This is a kind of one of the common problem will occurs in a real-time scenario. Okay, so now what we need to do? Again, we need to copy this 100 GB data from this production to non-production environment. for this testing purpose. So now basically when we are doing this particular copy, what will happen, again it is going to again it is going to occupy 100 GB storage in dev environment. So I need to pay for that 100 GB. Am I right? So this is one of the common scenario. And if you see like this, there are so many scenarios will come across. So now like in the production database also, the databases are getting bigger, right? Every day by day, the data is going to increase. And if you need to fulfill the user business cases, you need to do so many data copies, right? So now if you see the traditional data warehouse also, we have seen one of the common problem, data marts or data silos, which means like you have already brought the data into the data warehouse. Now there is a particular team, financial team, they said, hey, my financial data, I don't want to be give access to anybody. I just need a separate database for me. So now you need to extract that financial related information from that particular data warehouse, and you are going to create a data mart on top of that. So that particular data mart is going to be consumed only financial team. You are not granting anybody. So if tomorrow somebody else is coming and they also want this financial data, but already the database whatever have data mart whatever you have created, that is only dedicated for the particular team. So now again you need to copy another data mart and you need to give access to that particular other team. So after certain years of time, if you see, so many data duplications are created as part of this data marts replication. So now similarly, like if you are copying all these data marts or databases every time, so behind the scenes you are burdening with a additional storage cost, right? Basically here you are going to make a physical copy of the table. See, it could be table, it could be database, whatever it may be. Ultimately you are going to occupy additional storage and you are going to pay for it, right? So this is a common problems we are facing in a traditional data warehouses or whatever the current systems are available in the market. So most of the systems, when we are dealing with the physical copies, so and you are going to end with the paying additional storage cost for it. So now many common tasks require copies. As I mentioned, test development QA environments, right? So non-production environment always will go out of sync after certain period. So now every quarter or every 6 months or every 3 months, we used to request the admin teams in a traditional data warehouses and we used to ask them, can you please refresh these environments with respect to the production environment? If there are any sensitive information, they will just exclude those sensitive information and only that non-sensitive information they'll refresh with this in dev test environment, so that you can perform testing in a better way, so that you can almost you can compare with the production. It is a near real-time production data, right? So that you can execute your queries, you can see what are the challenges or what are the risks it might come across in the production environment and you can fix it upfront itself. So in order to achieve this, you need to copy this data multiple times. And ongoing maintenance challenges, which means the data continues to change in the production and need a copy to update, and promoting test production challenge. So this is what we are discussing. And cost, need to pay for storing multiple copies of the data. So these are the common challenges we are facing in real-time projects with respect to the current systems. I'm not talking about the Snowflake. Okay. So now how the Snowflake is going to address this problem, we'll see. So that's where this particular cloning will come into the picture. So far we were discussing about the physical data moving, right? Physically we are creating that a copy of the data, which means we are occupying additional storage. But coming to the zero copy cloning, or see the name itself, it is specifying zero copy cloning. Okay, so what is meaning by cloning? So cloning in general meaning also, like if when you do this cloning from nurseries and all, they used to clone these different flower plants, right? So they can get a same, and they can for one plant they can clone with some different flower plants, and they can organize in a single plant. It can give different kind of flavors of flowers and all, right? So similarly, now coming to the Snowflake, what is mean by cloning is a snapshot in point in time, which means whenever you are going to clone this particular database or a particular object, it is just replicate the data at the point in time. But the beauty of this cloning is it is not going to store, it is not going to occupy any additional storage. That is the most important thing here. And it is useful for audits and complaints, and useful for basic backup, cost saving. How cost saving? As I mentioned, now if you want to copy that 100 GB data into a dev environment, so basically you are physically copying this from data from this dev production to dev. So there you are going to occupy another 100 GB storage. But coming to the cloning, so the cloning is not going to occupy any additional storage until you modify the cloning table. So now, for example, I have a table, 1 GB of data is there in the table. Okay. So now I just simply clone that particular table. So now the base table and clone table both are independent. You can modify base table independently with respect to the clone table, vice versa. Like you can modify the clone table with respect to the base table. So now when I clone this particular 1 GB table, automatically another 1 GB table will be created after cloning, but the size, that storage is not going to be occupied for the cloned object until you modify that particular table, until you modify for the particular table. So now, for example, my non-production environment is completely out of sync. So I need to completely clean it off, this dev environment. So now basically I want to replicate the production database into non-production. So now I just excluded the sensitive information and I just clone the this entire database in dev environment. So now my entire database is kind of a almost 500 TB are there. So now when I'm going to clone this 500 TB, so additionally I'm getting another 500 TB storage free of cost. Later, whenever you are doing a DML operations, at that time it will occupy some storage and you need to pay for it. But until you modify the objects, it is not going to be occupy any storage. How, like why it is not going to occupy any storage? Because what it will do the sharing, what it will do the cloning is basically it will share the micro partitions, same micro partitions. See now, for example, in this diagram, so we know whenever we store the data into the database or into the Snowflake data warehouse storage layer, so how the data is going to be organized in the form of micro partitions, right? When I have created a particular table, so the data will be split into the micro partitions, and those micro partitions will be stored in the database layer. So now when I clone this particular table, so what Snowflake will do, it won't create a new object completely, and it won't create any micro partitions. Behind the scenes, simply it will go and it will access the existing micro partitions, and it will basically this base table and clone table both are sharing these micro partitions. And it is whenever you are cloning, at that time point in data whatever is there, that particular data only it is going to be cloned and it is going to be shared with this micro partitions. So as I mentioned, the micro partitions are immutable, right? So now when you clone this particular prod environment to dev environment, So what are the micro partitions are there? It will just share these micro partitions from the dev environment. So if you modify something, automatically it will create a new micro partitions, right? So if you are doing something in the dev environment, so it will create a new partitions and it will occupy the storage for it. But if you are not modifying anything, same micro partitions will be shared. That's where this Snowflake zero copy cloning is avoiding the storage cost. It's not occupying any additional storage. Is it clear? Anybody has any confusion, any doubt with respect to the cloning? How the cloning will work in a Snowflake? How this cloning is going to be helpful in real-time scenarios?
Sir, I have a doubt, sir.
Yes, please.
If this is a if they are going to share the micro partition,
Yes.
now the upper diagram is showing that whatever the changes you made in development, same changes will reflect in production also, or
No,
whatever the.
no. So this is diagram is a presentation for it is just sharing the micro partitions. It won't
Okay.
reflect in the production. It is just sharing the whatever the prod micro partitions are there, those micro partitions just sharing by the dev. So now if you see the down diagram, these are the initial micro partitions from the table A, and I have shared, I have a clone this particular table. So when I clone table A, so the same micro partitions will be shared. If I do something with respect to this particular micro partition, so those changes will be stored in the clone table and clone database, and you need to pay for it.
So suppose if there was a existing folder called as production folder, I
Yes.
created a development folder, and then I have cloned all these things from production to
Yep.
development.
Yep.
So that means now both are sharing the same micro partition.
Yes. So
Now if
when
I'm
you
making a now if I'm making a change in development,
hmm,
suppose I'm making some changes in development, so that development will reflect that development will create another storage,
yes,
and this is what you can see. I can see in this below diagram that.
yes,
So this is
so
after making changes,
yes.
or
So
else they would.
this change won't reflect into the base table. See, the
Mhm,
clone table is basically going to share the base table micro partitions. But
mhm.
whatever the modifications you are doing in a both tables, either it could be in a base table or it could be in a clone table, or it's a base database or clone database, both are it will work independently. It won't share those changes. It will work as a independent objects. When
Okay,
initially when you do the cloning, at that time it will share the micro partitions. That's where you can avoid the majority portion of the storage. But once you started modifying the tables, that is a different use case, because in the cloned object, it is a kind of, it will act as a independent object. So based on your use case, you can modify accordingly. You are not going to touch the base table, right? See, now I have a, in production I have a one particular table, customer table is there. Okay, so now the customer table having 1 GB of storage. So now my requirement is I want to test it some logic by updating the couple of records in that particular customer table. So now
mhm.
ideally in the production table, it is not a recommended approach. It is not a good approach to directly touch the production information. If something goes wrong, it will impact the live reports and all, because now in that customer table we have a three layers: in staging layer, integration layer, and int layer. So in integration layer I have built the kind of doing all transformations under the base table is there. In int layer, in prior layer I have created a view where I am seeing for each customer how many products they have purchased and what is the total cost for that product, particular products. So now if I am modifying something in this particular int layer, directly it will impact the view. So views going to be consumed by the business, and if you triggering something in this base table, automatically it will impact the real time reports and all, because all the reports build on the PRS layer, right? And the PRS layer views are depend on the int table. So you want to test it one new logic. So how you are going to test that particular logic? If you are applying that particular direct logic into this particular int table, it is going to be impacted the direct business, right? That is not a recommended way. So what is the best way? You can clone that particular table. In that clone table, you can test it your logic by deleting some records, by updating some records, whatever you want. Once everything is done, you can remove the clone table. So such a way, you are not going to create any impact on the business. Without impacting any business, you are going to test your logic by applying that particular use case, whatever you have. So in such kind of real-time scenarios, this is really helpful. And in this particular case, there is no use of sharing your cloned object modifications with respect to the main table, right? So the main table is dedicated for the business, and the clone table is, it is kind of for your convenience and your use case. It could be you are going to take a backup. For example, I am going to do some modifications with respect to the customer table. So always it is the best approach, best practice in real time. First we'll take a backup of the table. If something goes wrong, we can restore the table, right? So you can take a backup and you can do that whatever you want. If everything goes success, that is fine. If something goes wrong in middle, you just revert the table from this particular backup table, so that you have a kind of a plan B also in your hand. And in order to take all these backups, see in a daily basis, how many tables we are going to modify, how many times you are going to take a backup. So if you want to take a backup like this, without cloning, you need to pay for all the storage. But if you are going to use this copy cloning, Snowflake is saving lot of storage cost for our use cases. This is the kind of a advantage in a real-time projects.
Sir, in company, why do we use explicitly? Do we use coding for most of the time?
I didn't get you.
Like if I have to do some like in SQL, if there is a data, if there is a table,
Hmm.
we create a view or something like that, and
Yes.
then we use it for making what you call as a tableau presentation.
Yes.
So similarly, so that we don't make changes over there in the main table.
Yes.
So similarly, what is the use of Snowflake over here? Cloning.
This is what I just mentioned, right? If you want to create a testing in non-prod environments based on the production data, you can directly clone this entire database. You can spin immediately within fraction of minutes. So now ideally, as I mentioned, this is what I'm staying from last couple of minutes, right? If you want to
Mhm,
take a backup, if without taking a cloning, without using this cloning, if you are taking those backups, you need to pay for storage.
mhm,
Always, it is a best practice. We are going to take a backups for the DML modifications or delete and all in the base tables. So
mhm,
whenever you are implementing some DML changes, first we will take as a backup. Either it could be DML or DDL. First we'll take as a backup, then only we'll implement those changes. So in middle something goes wrong, how you will revert the back the data? For example, I have a customer table. I don't have any backup for the customer table. I'm supposed to update only particular location information, but by mistakenly I have updated all the departments information. For example, take
mhm.
employee table is there. I have 10, 20, 30 departments are there. So I'm supposed to update only 10th department data, but by mistakenly I have updated all the departments data. So now how I can get back the data? I don't have any backup.
Okay,
So one way is I can use the time traveling and I can go back and I can get the data. But again, the time traveling also it is a cost associated. And I need to travel back. I need to get back the data and I need to restore that particular table. And again, I need to see all the validations and all. But instead of doing all this crap, I can simply take a backup and I can go ahead and I can implement the DML changes. If something goes wrong, I can just restore the backup table.
okay,
Simple, right? So
yes,
in a real times, how this cloning is going to helpful? This is what I'm saying from last couple of minutes. So this is important thing. So in Snowflake account, as I mentioned, multiple environments will be there. So without zero copy cloning, if you want to replicate the production data in non-prod, it is going to be cost associated. But by using this cloning, you can just fraction of minutes, you can spin up the your test environment or your dev environment. So now in ideally in old days and legacy systems, every quarterly once we need to raise a request to the support team or admin team saying, hey, we need to do this performance testing. I need to see my query how much time is going to take it. But in non-prod, I mean to say in dev or testing environment, we don't have a sufficient information. Can you please refresh the prod data into these environments? So once you raise this request, it will go certain approvals and all. Once everybody is approved, because it is a cost, it is a storage associated, right? Additionally, they need some additional storage. So once they have approved, then this admin team, they can manually create a script and they will refresh the production data into the non-prod environments. I mean to say, in production entire database, they'll just replicate into the non-prod. But again, after 3 months, it will go out of sync. Then again, you need to refresh it. So this is a kind of a tedious task. Every time you need to raise a request, you need to wait for approvals. Once you got the approvals, you need to follow up the admin teams. Once they refresh the data, then only you can go ahead and you can test your use cases. But that is a kind of a repetitive task. But coming to the cloning, so like no approvals, no nothing. It's just a matter of, if you have admin access, you can just clone yourself. If you don't have admin access, you can just try to reach out admin. They can just simply clone it, because it is not any additional cost associated, right? It is just taking a snapshot of that entire database. So for example, in the database, there are thousands of objects are there. All thousands of objects is going to be replicated in the clone database. So until you are going to modify those objects, it is not going to occupy any storage. Once you started modifying the tables and all, it will occupy additional storage, because the new micro partitions will be created for that particular storage. You need to pay it. If somebody is asking during interviews, so what is the use of cloning? You can give these scenarios. So these are the problems in real time legacy systems and all, but by using this cloning, we can avoid this. So I especially use this cloning while taking a backups. Whenever we are performing any DDL or DML changes, we used to take a backup of those objects. So we will clone those objects as a backup option. So this is how we can save the storage cost. And another important thing is here is, both base table and clone table both are independent. Whatever the changes you are doing in a base table, it won't reflect in the clone table, and whatever the changes you are doing in a clone table, it won't reflect in the base table. Only when you are initially cloned, at that time only the data will be replicated. I mean to be say, it is a copied into the clone table. Post that, it is up to you. So this is a kind of a syntax: create or replace database or schema, table, stream, whatever you want to clone, and clone that source base table name. For example, if I want to employee table, I want to be cloned. So create or replace table employee underscore clone from clone this particular table, base table. And along with the time traveling option also, you can use this cloning. So we'll see that in as part of demo, how we are going to use it. So now coming to the, when we are cloning to the database, what will happen? Basically, database, it contains the different kind of objects. So what are the clonable objects and what are the non-clonable objects? Which means when I clone this particular database, what are the objects will clone into the clone database and what are the objects will not come by default? This is another important interview question and another important Snowflake certification question as well. So they'll give list of items. Please find out these, what are the objects can be cloned. So when you clone inside that particular database, stages, file formats, sequences, tasks, pipes, everything will be cloned. And coming to the non-clonable objects, external tables, internal stages, materialized views, shares we need to discuss. So these components, you cannot clone it. Even though you are cloning the database, inside the database, if these objects are available, those objects, it won't reflect into the clone database, but other all objects will be available in the clone object. Any doubt?
No, sir.
Okay. So what are the kind of a key points we need to remember when we're doing the cloning? So often used to quickly spin up dev or test environments. So this is what we are discussing now. Just now we have given a real-time scenario, right? Real-time example. So in the Snowflake account, we have multiple environments. So if you want to make it a sync non-prod environment to the production environment, you can just simply can do fraction of minutes based on the data volume. This cloning. And the cloned object is writable and it is independent of the cloned source. That means the change made to the either the source object or the cloned object are not part of the each other. When you are cloned, initially it will share the micro partitions, but post that, what are the changes you are doing, both are independently will work. Since cloning doesn't copy the load metadata, already processed file can be reprocessed into the clone table. So which means, right, like when we are applying a copy into that particular table, once the file is copied, we cannot copy it again, right? We have already seen that because this load metadata is not copied. But recently, I think last couple of months or last 1 month before, they have changed this behavior also. When we are cloning, that metadata also will be copied. So you cannot reprocess the same file again. So this is wiped out. Now it's not required. So Snowflake every week it will do their release and they will send the notification also. So this is also most important. That is the one of the reason I am sharing always the documentation notes, because I'll be training multiple batches. I'll be using the same reference material. But recently they're coming up with so many changes. I'm trying to best to accommodate that latest changes in each and every training program. But always better to go through the documentation so that we'll get the up-to-date information. Okay. So now the clone table, you need a select privileges on the source table for pipes, streams, tasks. Need a ownership for all other objects that can be cloned by you, need to the usage privilege. So what does mean? For example, I'm going to clone one particular database. So whenever I'm cloning that particular database, so at least I need a select access for the source tables, pipes, streams, and tasks. For all these objects, if I have a read access, then I can able to successfully clone those objects. If I don't have any privilege, I cannot clone it, right? It is a basic thing. If I have a read privilege, at least I can clone those objects about tables, pipes, streams, and tasks. Now coming to the other objects, you need as a kind of a, for pipe, streams, tasks need a ownership. Only tables, you need a select privilege.